Welcome to all the students, and we are continuing with November 2023 paper 1, question 9 and 10. Let's get started. So typically, question 9, we expect the practical applications of differentiation. So let's look at the question. In the diagram below represents a printed poster. Rectangle ABCD is the part on which the text is printed. So it's the section in between, in the middle. The shaded area, ABC, is 432 squared centimeters. AD is X centimeter, so that would be X. ABCD is 4 centimeters from the left and right edges, and 3 centimeters from the top and bottom. So the diagram already has all the info then on it. Now they're asking me to show that the total area of the page is given by this expression. So remember, when we work with these practical applications, the best method to start is I always look at what I want and compare it to what I've got. So what do I want? The area of the total rectangle or the total paper. So we know that area is equal to length times breadth. So now I need to go back and see if I've got an expression or values or something for it. So let's quickly have a look. So if this is X, just to make my life easier, I will make this side CD of the rectangle Y. So this is Y and this is X. So if I were to compare it with the larger part or the larger piece of paper, look carefully to get this full length from here to here. I would simply have to say that this piece is Y and the top piece is 3 centimeters and 3 centimeters. So this would give me my total length of Y plus 3 centimeters. Then if I compare it like this, do exactly the same. So again, it would be X, 4 and 4. So it's X plus 4 centimeters. I will now start to simplify it, but keep it as is. So when I answer the question, I will first substitute it in and say it's X plus 4 multiplied with Y plus 3. So we'll get X plus 8 multiplied with Y plus 6. Right, but now I have 2 variables. So what can I do? This is what I want, and this is how far I can take it. Now I've got to look what other information did they give us. Back to the question then. The shaded area of the smaller rectangle is 432 squared centimeters. So what does that mean? Well, let's have a look. We know that the area of the shaded rectangle would be length times breadth, which in our sketch is X times Y. But now they stipulated it's equal to 432 squared centimeters, which means Y will be equal to 432 over X centimeters. And this is perfect because now I can use this and substitute it back into the equation, as I would prefer only to work with X values from now on. So I have X plus 8 multiplied with 432 over X plus 6. Now I need to multiply it and try and simplify. So I'll get 432 plus 6x plus 3,456 over x plus 48. Now I just need to simplify it. So 3,456 over x plus 6x, and we can add these two, and we will get a value of 480. And very important, make sure it's exactly what they asked for. Let's quickly check. And yes, 100% correct. And now for 3 marks, determine the value for x that the total area is a minimum. So remember, if you hear the word minimum or maximum, I want you to get the turning point for me, the x value of the turning point. So what do we know? The first derivative will be equal to 0. And that's what we'll use, that property. So let's get started. So if that's my equation, and just make a note of it, if you didn't get that equation, you could use the one they provided. Or if yours didn't get the exact same value, you can use their answer. So I know then for 9.2, I first need to get the first derivative. But once again, the format is incorrect. So it is 3,456 times x to the negative 1 plus 6x plus 480. Now I can quickly get my first derivative, and it's negative 3,456 x to the power of negative 2 plus 6. Remember, the constant values will fall away. Now I have negative 3,456 over x squared plus 6. And what do I know? At a minimum or a maximum, my first derivative will be 0. And now I need to solve for x. So I would simply go and say negative 6 is equal to negative 3,456 over x squared. Quickly multiply out with the x squared for me. We divide by the negative 6. So you'll get x squared is equal to 576. How do I solve for x? Now, typically, I would prefer you factorize, but think about it. X can't be negative. So if I just take the square root over both of them, I'll get x equal to 24 centimeters or negative 24 centimeters, which is not applicable. It's a length. So we can't use a negative. So you can either write it down and just say not applicable, or just leave it out. It has to be positive every time. Let's quickly get into question 10. So now we start with the probability questions. A and B are independent events, with the probability of A being a third, probability of B being 3/4. Determine P A and B, and P at least one event occurs. Very important. Independent. Immediately I know that the probability of A and B is equal to the probability of A times the probability of B. Let's quickly do that, because that's actually the first question. So we'll say 10.1.1. The probability of A and B is equal to the probability of A multiplied with the probability of B. So it's a third multiplied with 3/4, and you get a quarter. And that's the first answer. So if we were now to look further into this, they're asking for the probability of at least one, meaning it can be more than one event, for example, A and B. So how will I approach it? Well, I would prefer to use rather the equation that says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So that equation, that is on your formula sheet. And now I just substitute the values that I do have. So I do have a third plus 3/4 minus the quarter we just calculated. And the final answer would be 5/6. Now, very important, if you wanted to do it graphically with a Venn diagram, you were more than welcome. it would have been easy. So there's just a few things we need to see. So obviously, because we know it's independent, we know there's a section where it overlaps. So if this is A and this is B, we know it's a quarter. So that third we have of the probability of A would actually be a third minus the quarter. Remember, the overlap section must be subtracted. And on this side, I would have 3/4 minus 1/4 as well. So if I calculate that, I will get 1/12, 1/4, and then 1/2. And just for interest's sake, please remember, if we add this up and we don't get 1, it means that there are actually some values here, which is not A or B at all. And we would get it by saying 1 minus a 12 minus a quarter minus a half. And whatever remains, that would be the value on the outer section of this Venn diagram. Now, because they only asked literally for at least one event, they are referring to these areas here, like everything in the two circles. So literally, I could have just added everything up by saying a 12 plus 1/4 plus a half, and you would still get 5/6. Same answer. Doesn't matter how you approach it, just make sure you show every single step. Right, let's quickly do the next part, 10.2. The probability that it will snow on the Drakensberg Mountains in June is 5%. When it snows, the probability that the minimum temp in the central South Africa will drop below 0 is 72%. If it does not snow, the probability that the temperature will drop below 0 is 35%. Represent the given information on a tree diagram. Clearly indicate the probabilities associated with each branch. So right, what are we looking at? First of all, we need a branch for snow or no snow. So let's get going. So the first branch would simply be to distinguish when it's snow, when there are snow or no snow. So the probability for snow is 0,05. In other words, the 5%, which means the probability for no snow would be 0,95. Remember, they are complementary. They must add up to 1. Now, when it snows, we need to look, or when it snows, we have to look at below 0 degrees or not below 0 degrees. And the same for the second section. So below 0 and then not below 0 degrees. And now we can look at the question again. So if it snows, we can expect a minimum temperature of 0 degrees, a 72% likelihood. So that means that would be 0,72, meaning this would be 0,28, the 1 minus the 0,72. Then if we look further, go back 35% for the second branch to have temperatures below 0. So that would be 0,35 and 0,65. Again, complementary, it must add up to a value of 1. Right, now we need to look at what else do they want from this tree diagram. Let's go back. Calculate the probability that the temperature of the central South Africa will not drop below the 0 degrees Celsius in June. So we're looking for all the branches where it won't drop below 0. So if we look, it would be this branch and then this branch. So how do we calculate the probabilities? When we're using one branch, we multiply, meaning the 0,05 multiplied with 0,28, or 0,95 times 0,65. But these are two separate branches, so we need to add the the two answers. Let's quickly jot it down. So the probability of not below 0 degrees would be equal to 0,05 times 0,28 plus 0,95 times 0,65. And you will get an answer of 0,6315. So very important, if they were to ask you for the percentage likelihood for the temperatures to not be below 0 degrees, you would just multiply that with 100, and it would be 63,15%. So very important, here preferably use about 4 decimals where possible to help you to have the most accurate answer. So let's quickly do the last question. So 10.3, again, still probability. 10 learners stand randomly in a line, one behind the other. In how many different ways can 10 learners stand in a line? That's simply 10 factorial. Because there's no specific order we're looking for, the 10 can just rotate, and as soon as the one spot is filled, for example, the first spot, there are 9 spots left. So 10 factorial. Now we look at 10.3.2. Calculate the probability that there will be 5 learners between the 2 youngest learners in the line. So the best way here is to actually draw it out. So if I've got this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the 10 learners, and I know there must be 5 learners between the 2 youngest ones. So this is the first spot, then there's 1, 2, 3, 4, 5 spots, and then there must be another, the second youngest learner. So if I compare that, it means on the first spot there can be 2 of them. It's one of the youngest ones we can use. And it means here you'll have only one option left. Now in between, if you look here, I already filled 2 of the spots. So there are 8 students left for the rest. So there would be 8, then there would be 7, 6, 5, 4, 3, 2, 1. And we can just multiply it with each other. And we would get 80,640. But now remember, the younger students can actually move, because if I move them one spot to that side, as long as there are 5 students in between, it's still an option. So quickly look, if we do this again, 6, 7, 8, 9, 10, and we just move them one spot over, you'll get again a 2 and a 1. But then it's 8, 7, 6, 5, 4, 3, 2, 1. So again, we'll get the 80,640 options. So if you look carefully, if you look at this last student, he can still move another 2 places. So actually, we have 4 arrangements we are looking at for us to fulfill the requirements they're asking for. So the total amount, if you look at it like this, the total number of outcomes for 5 between the 2 would be 4 times the 80,640, which would give you a total of 322,560. But remember, these are the total of outcomes. They're specifically asking for your probability, meaning the probability for 5 between 2 would be equal to the total of outcomes we want over the total number of outcomes in general. And your final answer then would be 4 over 45. And that is all for paper 1. Good luck with the exams and see you in paper 2.